So before we get into what the complex expressions of a sine wave are, it will be helpful to discuss why we actually need them. So let's say we want to do maths on two sine waves. Maybe we want to add them or multiply them or what have you. How will we go about doing that? Well, we could use calculus and that would get us the answer eventually. However, that would take a very long time and would be a massive pain. So we're not going to do that. Instead, we're going to convert these sine waves into a complex form, and this will simplify the process greatly, as you will see. So how do we actually get the complex expressions of a sine wave from the regular sine wave function? So as it turns out, a sine wave can be expressed either as a wave as it normally is, or as a rotating vector, and anything that can be expressed as a vector can be expressed as a complex number. So in order to extract the complex forms of a sine wave from the equation, let's say Vm sine omega t plus theta, in order to get the polar form of that, all you would do is you would take the amplitude Vm and put it to phase offset theta. That's it. It's not very complicated. And of course, in order to convert that into rectangular, all you will do is you will grab that and you will split it into its real and imaginary components. So for a given sine wave Vm at phase offset theta, you will express that as Vm cos theta plus jVm sine theta in order to get the rectangular form of that sine wave. It is important to note that omega does not matter, as that affects the speed of the rotation of the vector, which is not relevant. So how do we actually use the complex expressions of sine waves to do maths? So let's say if we wanted to multiply two sine waves together, the first step would be to extract both sine wave functions out of the equation that we're trying to solve and convert them both into polar form. And after you've done that, you'll just multiply them like you would any polar form complex number. So multiply the magnitudes and add the phase offsets, and in this case you will get 15 at 180 degrees. Adding and subtracting sine waves is a little more involved, as we have to use rectangular form, but the first step is still the same. Extract both sine wave functions from the equation and convert them into polar form. Once you have them in polar form, then convert them into rectangular form and use normal algebra to simplify that equation. Once you simplify that equation, you'll want to convert back to polar form, so just use Pythagoras to get the magnitude, and for the direction, just take the arctangent of the imaginary over the real to get your phase offset, and you should be set.